Welcome back to another video. Today we're looking at covalent bonding. Alright, so let's get into it. So 2.5 covalent bonding. What is covalent bonding? Alright, let's look at that real quick. Covalent bonding is when a pair of electrons is shared between two atoms. Okay, and we know in all these types of bonding, what the purpose of these bonding is in order to attain a noble gas electronic configuration, right? Configuration. And what I mean by this is they want a shell that has 8 electrons, whether they share it, whichever way, they want 8 full electrons. And in order to do that, covalent bonding occurs. Now, I need you to note that covalent bonding actually occurs between non-metal elements only. Okay, at your level, this is what you're supposed to know. So it always occurs between non-metals. And if you look at your periodic table, we have carbon, hydrogen, nitrogen, chlorine, all those non-metals. Okay, so that's the first point done. Second point, you need to be able to describe formation of covalent bonds using dot and cross diagrams. Now, if you don't like dot and cross diagrams, some people actually get tired of these diagrams, but they come so often in your exams, you need to know them. Okay, if you understand the basics of it, then it will come off very quick off the top of your head. So let's get into this real quick. Okay, let's start with hydrogen, the simplest one to do. So hydrogen, we know, has 1 electron. So here you go, 1 over here and another over here. Now these both, according to a full electronic shell, the first electronic shell should be 2 in order to be full. So if they say, hey, hydrogen, bring you one electron, I'll bring the other electron, and let's share up these pair of electrons and become a full and attain that full outer electron. There we go. That's basically it. So you have your dot and cross. Now, in the exam, they want you to draw this diagram because this is how the dot and cross diagrams of hydrogen bonding, or H2, in other words, occurs. So they both give one electron, and they form a covalent bond. Okay. Now let's look into chlorine. Okay. So chlorine, we know, has 17 electrons, which is arranged as 2, 8, 7. If you don't remember how to do electronic configuration, I'll link a video above so that you can refer to it. So now let's get back to this. So they have 7 electrons in their outer shell, which is what I've drawn out here. So each chlorine has 7 electrons, but they need that one more electron in order to get that full outer electronic configuration. So they say, hey, chlorine, I'll bring in 1 electron, you bring another electron. Okay, so dot from 1 and a cross of electron from 1. And we form a full shell electron. However, here's the trick. A lot of people tend to forget this and lose marks for this. Is sure, these are the shared pair of electrons, but chlorine here still has these electrons that are not drawn in here. Same applies for this chlorine. They all have to be drawn. You need to show all the outer electrons, not just the covalently bonded. So I need to show that chlorine obviously had these electrons that are not bonded, but are in its outer shell electron, and these need to be represented. So a lot of people just draw this covalent bond, these shared pair of electrons, and forget these outer electrons, and that will lose you a mark because that is not a full outer shell electron. Okay, let's do another one. Actually, we're doing nitrogen. Okay, actually, let's do oxygen first. So oxygen here, like I've written here, has an electronic configuration of 2, 6. It has 8 electrons. Its outer electron has 6, and that's what you're supposed to draw when you're asked to draw electronic dot and cross diagrams, okay, of atoms and elements. So like I said, oxygen has 6 electrons each, and if oxygen, so this is a scenario where they don't necessarily contribute just 1 electron, but actually 2 electrons. So contributes a dot, across, a dot, and a cross. If each oxygen contributes 2 electrons each, like I've shown you before. And we know that these oxygens already have 6. So if they've contributed 2, that means they have 4 more that have not been paired. So 4 more that has not been paired. So if I count, we have 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons for this one. This other one also has 1, 2, 3, 4. 5, 6, 7, 8. So each oxygen actually has 8 electrons. Now, if I want to represent this oxygen and the bonding that happens in this oxygen molecule, it's going to be O double bond. This is where double bond is created, okay? And it's written as O2 because there's 2 of them. Let's go to nitrogen here. This is another one where nitrogen, we know, has 7 electrons. And if we want to do the electronic configuration, that would be 2, 8, 5. So 5 electron is the outer shell electron, like I said, that you need to draw. So we have each nitrogen with 1, 2, 3, 4, 5 electrons. And if they can't just share 1 electron, because then they'll have 6 each, they want 8 electrons. So if they want 8, that means they both need to contribute a lot. So that will be 3 electrons. Each nitrogen brings in 3 electrons, okay? Each nitrogen contributes. So this is basically a give and take. So if they want to share, they need to both put the electrons on the table. So we need, remember, never forget the ones that have not been bonded. If we know that 3 of these have been bonded, 3 of this have been bonded, then there are 2 more that are, okay, don't know what happened there. Then there are 1, 2, that are not bonded. So I need to draw my dots that are not bonded. And remember, you want to pair them up all the time. If you have even numbers, and the odd number will be alone, and that's all right. So there's 1, 2 from this side that have not been paired. So if I count the number of electrons that I have here, we have 1, 2, 3, 4, 5, 6, 7, 8 for this one, and it's going to be the same for the other nitrogen. And to represent the covalent bonding in nitrogen, because they've both contributed 3 electrons, it's not going to have double, it's not going to have single, it's going to have triple bonding. But it's still going to be written as N2, which is a lot of people forget. It is not, it is triple bonding because there are 3 electrons shared between these nitrogen molecules. However, there's only 2 nitrogen molecules involved, so it's N2. All right? Now let's get into hydrogen chloride or hydrochloric acid, bonding between hydrogen and chlorine. We know hydrogen in here wants 1 electron. There's this missing spot for an electron. Chlorine also has this missing spot for electron. They both just need 1 electron to be full, to be stable. So here, I'll have my H, my Cl, and I like to actually draw the outer ones first so that I don't forget them. That's a good way to make sure you don't forget those ones, because we're humans, it occurs very naturally. You forget the outer ones. So for chlorine, I'm going to draw my 2. We know it has 7, but it's going to keep the 6 and contribute that 1. Okay, and hydrogen only has 1, so I don't need to draw the other ones because it doesn't have other ones. So there we go. So we know hydrogen has 2 electrons on its outer shell, which makes it full, and chlorine has 7, which is also full. So this is a covalent bonding between 2 different atoms. All right, let's do another one. What do you want to do? Okay, there we go. C2H4. C2H4. Oh, no, sorry, that's CH4. Sorry. CH4. So carbon has 4 electrons and it needs 4 more, okay? Hydrogen has 1 electron each, but they all need 1 more as well. So what can we do? We can give 1 electron and bond them each to each hydrogen that are here, okay? So that would give us some sort of image like this. We know that carbon has 4 electrons, so it's going to give each electron to its hydrogen. And then these hydrogens each also have their 1 electron, like that. So there we go. That's already this is one of the simplest ones when you actually think about it, okay? So if we look closer, these ones the dots come from hydrogen, the crosses come from carbon. And carbon already has 1, 2, 3, 4, 5, 6, 7, and 8 electrons. So there's no other electrons because it only has 4, and all 4 of those electrons are bonded, so we don't have to be worrying about the unbonded or unpaired electrons around here. So that's it. So basically 2 tells you to do some dot and cross diagrams. I've not done some for some of these atoms or some of these molecules, but this notes that I'll be sharing on the link below will have all of these bonds on and we'll have the dot and cross diagrams along with it, so you can follow along, check them out, and make sure whenever you've learnt one, try to not look at it and do it again, repeat it. It comes off of nature the more you do it. All right. And we've also done some of the covalent bonds of the harder ones, I would say. So the nitrogen, the oxygen, we've done all of those. Again, I don't have time to do all of these bonding because that's a lot of it, and it's going to be a longer video, and you will have hard time trying to watch this, because I know I will. So let's talk a bit about the properties. Okay, properties of these these simple molecular structures, and we're going to relate them to the type of bonding and structure there is. Okay, so we're going to talk, let me change the color, properties of simple molecular structures. Molecular structures. The first one is they have low melting. They have low melting and boiling points. Okay, boiling points. Why is this? Why do they have low melting and boiling points? This is because they have, decrease that a little bit. This is because they have weak, I don't know what's wrong with my pen, with my stylus, intermolecular bonds, okay? What does this mean? What does this intermolecular, okay? Means weak bonds between molecules. So if you look at these bonding, let's look at chlorine. The bonds between Cl and Cl is weak, okay? This bond, this shared pair of bonds created is weak. So that results in a low boiling and melting point. One trend to keep in note is even though these intermolecular forces are weak, going down the group, or the larger the molecule, relatively, okay, we need to know it's relatively, obviously, relatively the intermolecular bonds. Okay, I don't know what's going on with the stylus. Intermolecular bond becomes stronger. Okay, so if I look at the bond between, here, we have a side-to-side comparison. If I look at the bond between hydrogen atom and a chlorine atom, because there are more electrons present between chlorine than hydrogen, we know that chlorine bond is way more stronger than hydrogen bond, okay? And which is why the melting points of, let's say, a hydrogen molecule, I've never tried to melt a hydrogen gas, but is lower than a chlorine molecule. Okay, so that's the first point done here, and that's low melting points done as well. Now let's talk about poor electrical conductivity. Have you ever used, let's say, let me use this, electrical conductivity, poor electrical conductivity. Have you ever used nonmetals like in I cannot even come up with any nonmetals out here. So what do you have? Have you ever used wood, plastic? Do they conduct electricity? They don't, because they are poor conductors, okay? They cannot conduct electricity. Poor electricity conductors are also known as good insulators, right? And these simple molecular structures compounds, right? They have covalent bonds. Okay? They are covalent compounds and hence cannot conduct electricity. And if you're wondering, why cannot they conduct electricity? Because in order, let's say I have, what do we have? Let's say this is a battery, okay? And I have a wire to connect it with a bulb, okay? My drawing is not perfect. Let's say this is the little bulb. I even want to color it orange to get that, brightness. Okay, so I have this, right? In order to conduct electricity, I need something to carry charge, right? Because there's no other connection between this battery and bulb, I need something to carry charge from here to here. And because these covalent compounds actually, they don't have any free ions, to carry charge. Okay? And hence they cannot conduct electricity. So whenever you ask questions, oh, why can't covalent compounds conduct electricity? They don't have any free ions to carry charge, okay? And that hence makes them insulators. So that's it actually. It's a very, very interesting unit. We've covered everything out here. You can refer to the notes to recall some of these dot and cross diagrams because these are the ones that are actually going to come in your exam. Nothing new is going to come. So if you know all of these dot and cross diagrams, then that means you're good to go in those questions in your paper. So thank you for watching this video again and see you in another video.